Alright, reducing and simplifying once again. You know this one's going to be a real beast because they've given us the answer. They wrote this and then they felt bad for how mean they were being to us, so they're telling us where we need to end up. Alright, well, we'll ignore that for the time being and come back to it. We'll see what we can do with this. First thing we want to do, you remember, is factor everything in sight and see if we can get any cancellations. So 2a plus 7 is a binomial. You don't, aside from common factors, you can't do anything with those. Here are two numbers that add up to 7 and multiply to 12. That's easy enough. And then 2a over difference of squares. Did you notice? It's unusual to have the variable in the second spot, but there's nothing wrong with it. This factors as 3 plus a, 3 minus a. Now, I wrote 3 plus a there. That's exactly the same as a plus 3, so I'm just going to switch that around to avoid rewriting this entire thing for one little piece. A plus 3, that's better. I can't do that here, well, unless I were to write minus a plus 3, which would look lousy. I'll leave that one in 3 minus a form for the time being, and we'll change it if we have to. So now, if we're looking for a common denominator, this fraction contains a plus 3, so does this one, so good, no need to change that. A plus 4 is over here, so we need it here as well. And 3 minus a is in the right-hand fraction, so we need it on the left as well. There's 3 minus a, and there's 3 minus a. So when we squish these together into one big fraction, it will contain a plus 3 and a plus 4 and 3 minus a. This bugs me a little bit more every time I write it. I may end up factoring out that minus 1 after all, but I'll hold off on it for a bit longer. This needs to be FOILed. 2a times 3 makes 6a. 2a times minus a makes minus 2a squared. 7 times 3 is 21. 7 times minus a is minus 7a. And over here, 2a times a makes 2a squared. And 2a times 4 makes 8a. So now, I'll just recopy the denominator again. You may hear some light tooth grinding as I write 3 minus a, but I'll let it go. So, minus 2a squared plus 2a squared. That's nice. They cancel completely. That's a rare treat. 6a minus 7a makes negative a, plus 8a leaves us with 7a, and then we have plus 21. Do we stop? No, we don't. We've got a common factor here of 7. So pop back up here. Factor 7 out of the numerator, and that gives us a plus 3. And downstairs we have the same stuff we've had all along. A plus 3, a plus 4, 3 minus a. We can cancel the a plus 3's, which gives us 7 over a plus 4, 3 minus a. Are we there? Uh-oh. Their solution has the a plus 4, so that's all right. But it doesn't have 3 minus a. It looks like they didn't like this either. They have a minus 3. Do you see how we could make that switch? We can't do it at will. Not quite, but here's what we can do. We have a plus 4. We can factor a negative 1 out of this term. Minus 1 comes out, and that leaves us with negative a divided by negative 1 makes a. 3 divided by negative 1 makes negative 3. That's more like it. Now we have the a minus 3 that they wanted, and you see how here we can do 7 divided by negative 1, and that's where the negative 7 comes from. These two plain old numbers are the ones you divide to get negative 7, and then left over from that we have a plus 4, which they wanted, and we have a minus 3, which they also wanted. So I wasn't positive that this thing would be so bad I was preparing myself to live with it, but it turns out their answer, they really did want these in descending order. So there we go. They wanted us to show that we could reduce this to the requested form, and we have delivered.